The introduction of Atmel Studio 6 has ushered in a new era of project portability between Atmel microcontroller families. Atmel Studio 6 is the next-generation integrated development environment, allowing you to develop and debug software for an AVR or ARM microcontroller. So whether you are working on a tiny, Mega, X-Mega, or UC3 AVR, or an ARM Cortex-3 or M4 CPU, the same efficient embedded design workflow is supported. Atmel Studio 6 and the Atmel Software Framework will facilitate the re-implementation of key application features with relative ease if your next project needs an ARM when previously you used an AVR or vice versa. This freedom of choice between Atmel 8 and 32-bit processors is facilitated by the Atmel Software Framework, or ASF, so understanding how to use ASF is an important part of this process. Before watching this video, we recommend you watch the ASF design process, which also introduces the structure of the Atmel Software Framework. Though a short summary will be given here. ASF facilitates a top-down software design process, so you are able to add services to your application and the dependent components and drivers are automatically added to your project. For example, if we add a USB device CDC service, the ASF wizard will automatically add the low-level USB driver to your project. For each service or driver added to the project, you can search the project database of over 1,000 examples for the example implementation closest to the application requirements. Sections of example code can then be copied into your application. The functions called in the example code may need to be modified, finding valid values using the intelligent editor and the ASF documentation. Certain services or drivers have associated configuration files. In this case, we may also need to find example projects to find configuration settings close to those of your application. Changing from one Atmel platform to another is just a special case of this design process. As you add services or drivers, you will copy the sections of application and configuration code for drivers and services from your existing application to the new one. Think of your existing application as a special example project, which is very close to your application requirements, so needs very little code modification. Even less modification will be required if your application uses ASF Common API. Atmel Software Framework API are either common or device-specific. Common API are independent of which Atmel microcontroller they run on. In a project which uses only Common API, both services and application layers will be identical, whether running on X-Mega, UC3, or Cortex-M micros. In the implementing a project with a device-specific API on a different Atmel micro, equivalent functions would need to be found at an API function level in order to implement similar functionality on the new platform. We start looking at the simplest Atmel processor platform change, a Common API example. Our starting point will be an X-Mega application which uses only Common API services from the Atmel Software Framework. Our endpoint will be the same application running on a SAM4S. The examples we will look at are the USB device HID mouse examples for the X-Mega B1 Explained and the SAM4S Explained. These respective projects will represent the starting and ending points of this video. Here are the steps that we will follow in this video in order to show how ASF can help us reuse much application layer code when re-implementing an existing application on a different Atmel processor. 1. Create a new example project from ASF USB device HID mouse on the X-Mega B1 Explained. 2. create a new user application template for the SAM4S explained. 3. Use ASF Wizard, add USB device HID mouse service to SAM4S, user application template. 4. Copy configuration file for USB service from Xmega to SAM project. 5. Copy application layer files from Xmega to SAM4 project, without modification because of common USB API. 6. Set the SAM4 clocks by referencing a SAM4 USB example project. 7. Copy the user interface layer from the Xmega to SAM project. This is board-specific, left to the user to complete. From the New Example Project Wizard, we filter project results by device family for Xmega. We filter by kit. In this case, our starting point is the Xmega B1 explained. Search for a keyword, USB, choosing the USB device HID mouse example. If we click on View Help, we can open the web-based help. Let's differentiate the project name to ensure that we know this is the Xmega project. Click OK to create the project. We can build this project by selecting Build Project from the Build menu. Naturally, the build succeeds with no errors. To check the target device, we can right-click on the project, selecting Properties. In the Device tab, we can see that this project uses the AT-Xmega 128B1. But we need more processing power for the features in our roadmap, so we would like to re-implement this application on an Atmel Cortex-M4 processor. Add a new empty project to the solution, based on the SAM3S EK. This is simply the Atmel Software Framework starting point, that is, the user application template for the SAM4S explained. To understand this project starting point, watch the video, The ASF Starting Point, Understanding the User Application Template. We will select to add this project to our solution. Give it a name indicating that it is for the SAM4S. For this new project, by checking the project properties, we can verify that the device is set to the AT-SAM4S16C. Now we can add the USB HID service to our project. Right-click on the SAM4S Explained project and open the ASF Wizard. This will ensure that you add ASF modules to the right project. We select the USB device HID service, adding this to our project. When we do this, the USB driver for SAM4S will automatically be added, as well as all the files related to the USB stack. Once we have added a service or driver to ASF, the next step in our process is to modify the relevant configuration files according to our application requirements. These will be the same between the Xmega and SAM4. In our Xmega application, we made some modifications to this file, so we directly overwrite the default file in our SAM4S project. conf.usb.h is the glue between the services and application layers, used to link the USB driver to the functions in our application layer. Now, if we build the project, we can see that ASF has taken care of the USB service and driver, and the project builds without any errors. We can now start the process of moving the application layers from the XMega to the SAM projects. At this point, if your project were a non-common API project, you would have to re-implement your application, looking for equivalent API from ASF at a services level. However, since this is a common API example, we can simply copy across the application layer, which consists of main.c and main.h from the XMega project to the SAM4. As we copy main.c from our XMega to our SAM4 project, notice how we can conveniently position these two files alongside each other in Studio. Next, we can copy main.h. To do this, we first create this header file in the source folder of our SAM4 project. Right-click on src folder and add New Item, Include File, naming it main.h. Into this file, we paste the contents of main.h from our XMega project. In this project, main.h contains the function prototypes that we use to link into the USB stack in conf usb.h. Next thing to do is configure the clock.s in our SAM4 project. This is something we can't copy from the XMega project, because naturally the SAM4 has a very different clocking structure. Another thing to keep in mind is that quite a specific clock frequency is usually required for any USB application. What we will do is open any SAM4 example USB project and copy the clock configuration from conf clock.h. We open this file and place it next to our current conf clock file to see how the clock configuration differs. In this case, we see that the SAM4 clock configuration for a USB application uses phase locked loop 1 as a USB clock source. We can simply uncomment the relevant lines of code. Then check that there are no other differences in the clock configuration file. We have no further use for the SAM4 USB example that we have added to our solution, so this can now be removed by right-clicking on the project and selecting. The last steps left in our project are the user interface part of our application. Part of this is platform independent, though some parts will have to be modified for our new board. The user interface consists of UI.c and UI.h. We open UI.h from the XMega project, then add a new header file item to the SAM4 project, calling it UI.h, opening this alongside UI.h from the XMega project, so that we can conveniently copy from one file to the next. We can now remove the code from all the functions in UI.c, as these are board-specific. Replacing this code is outside the scope of this video. For now, we will remove the code inside these functions. The code compiles, demonstrating that our XMega project is now almost completely re-implemented on SAM4, giving us the extra processing power we needed for features on our product roadmap. In this video, we have shown how the ASF design process has helped us reuse much application layer code when re-implementing an existing application on a different Atmel processor. 8. Created a new example project from ASF USB device HID mouse on the Xmega B1 Explained. 9. Create a new user application template for the SAM4S Explained. 10. Use ASF Wizard add USB device HID mouse service to SAM4S, user application template. 11. Copy configuration file for USB service from Xmega to SAM project. 12. Copy application layer files from Xmega to SAM4 project, without modification because of common USB API. 13. Set the SAM4 clocks by referencing a SAM4 USB example project. 14. Copy the user interface layer from the Xmega to SAM project. This is board-specific, left to the user to complete. In doing this, we have followed the ASF design process, starting from a user application template for the SAM4S Explained, adding the relevant drivers. We then added the USB device HID service using our existing application as the example project. This was a special example project, very close to our project requirements, so very little code modification was required. We then also referenced the configuration files of our existing application.